You hit the start button, but what actually happens? We're going to take you through the basics of how a bandsaw works, from pressing the start button to all the way to finishing a cut. So let's go over it. My name is Jeremy with I Machine Services. I've been servicing bandsaws for 20 years. I ask you guys to drop a comment if you can, to let us know if you have any other ideas for videos. So we're going to get into it. Okay, so I drew this stuff. It's very rudimentary. My drawing skills are mediocre at best. But we just want to go over the basics of a bandsaw that you can understand. Okay, so here I've got a pivot style bandsaw. You see he pivots. Some people call them scissor saws. Okay, but what we have is we have the head of the saw. Okay, and we have the base of the saw. Okay, you generally have some kind of clamping situation. And then I do want to go over this. There's several different power units when it comes to the machine. Okay, we have a mechanical system, we have hydraulic systems, we have pneumatic systems, and we have electrical systems. Not all machines will be pneumatic, and not all machines will be hydraulic. Okay, and some of these items that we'll talk about, some machines will do it mechanically, and others will do it with a cylinder that will give us power or pressure. Okay, so we have the head of the saw. We have two wheels, the band wheels. That is what the blade rides on. We've talked about that in another video before. You generally have a drive wheel. The drive wheel is where the power is going to come in. And then your secondary wheel is called your idle wheel. And then a lot of manufacturers call it different names, but I've always called it an idle wheel. The way you know the difference is the idle wheel will spin freely when there's no blade on it, and the drive wheel will not spin freely. If both wheels spin freely, either you have a very unique saw or something is wrong in the gearbox. Okay, so your blade's going to go over both wheels. I've got diagrammed right here, just a little cylinder. You're usually going to tension it somehow. You're going to spread the idle wheel out. Okay, generally it's the idle wheel. There's always exceptions to this, but generally it's the idle wheel that gets pushed out. It has a cylinder either on the inside or the outside that pushes or pulls, and it stretches it out to a predetermined pressure. If everything is set right, you'll get a predetermined amount of pressure on that blade. Okay. Sometimes this will be mechanical. Sometimes you'll have a hand crank, like a little screw system, and you got to do it by hand. Okay. Just depends. Okay. Now we have these two guide arms. Okay. These are going to be straight and rigid, and they're going to come down. Sometimes they'll come from the side. It will not always have to be coming straight down, but you have something that's going to hold the blade so that while it cuts, it holds the blade straight between those two guide arms. Okay. Between the bottom of this wheel and here, we're going to turn the blade. A lot of times it's 90 degrees. Some machines are not. You might have the wheels like this and the guides like this, so maybe it's less than 90 degrees. But let's say it's this way. You're going to take that blade and you're going to turn it 90 degrees. You're going to make your cut between the two guide arms, and you're going to turn him again another 90 degrees to the bottom of this wheel. Okay, so there's a lot of twisting of the blade. And then we have all that tension. Usually it's 20, 30,000 pounds per square inch of tension on. So there's a lot of action going on that blade. Okay, so we have him tensioned. We have him in the guides. So the head is ready to cut. In this case, see, the head is up. We also usually have some kind of way to secure the material. In this case, it's clamps. You have vice jaws. Okay, and then one of the clamps generally will articulate in and out somehow. Either it will be free moving, you can lock it in place and then lock it down with a hand screw. This one here, I've driven a cylinder. Again, it can be a hydraulic cylinder, it can be an air cylinder, it doesn't really matter. It depends on how the system is set up. Okay, now over here, I've shown a drive system. Okay, so what we have here, which I've poorly illustrated, is a electric motor and a 90-degree gearbox or gear reducer. Okay, so it takes the power in one direction on the input shaft and it pushes it out on the output shaft. Some machines, they'll have the motor plugs straight into the gearbox and turns. In this style here, we have a pulley system. Okay, so the pulley system will have a belt that usually goes between them. Usually it's a variable speed belt. You'll have two articulating pulleys, and then those will increase and decrease, and then that's what will change the speed. So you'll change the pulley. There's usually a hand crank on the pulley that will adjust the speed. Okay, and that's basically what you would consider your transmission. okay, which then turns that power 90 degrees. So generally this drive system is behind the drive wheel, okay, and then that gearbox shaft right here is what's going to stick through, and this wheel here is going to ride on, okay, and then he's going to turn, which turns him. Generally, there is a large reduction in speed. Most of these guys are 1, 2, 3,000 RPMs on the motor. You're not going to get 1, 2, 3,000 RPMs on this guy. Usually there's a 60, 75 to 1 gear ratio, something like that. Okay. So you're going to have a drive system. Over here, I've driven the cut and lift cylinders. A lot of times this is done with one cylinder. On almost all hydraulic saws, they don't need the double cylinder next to each other. You might have two cylinders, one on each side, if it's like a double column. But here I'm showing a different variant. So we have two cylinders. So if it's an air saw, if it is a pneumatic saw and there's no hydraulics per se, you still have to use hydraulics with a reservoir of some kind to make the head come down smooth. Okay, an air machine or pneumatic machine will use air. The cylinder will usually be right in here, okay, on this side of the pivot. Okay, some of them will have it back here. Just depends on how they do it. But they will lift the head with the air pressure, and then they will take the air pressure away and the head will drop. The problem with air or a pneumatic system is air is spongy. It is not firm. It is not good. It is good to compress. And so it'll act like a shock absorber. Okay, so you'll lift the head up, and as you remove the air, okay, it wants to drop. Okay, so you want to not take all the air out. The problem is it will bounce. Okay, and for cutting, that is very bad. Okay, so what they do in this case is they use a second cylinder and they put hydraulic oil in the second cylinder. So it acts like a dampener. Okay, and then they give you, the operator, the ability to adjust that second cylinder. Okay, and by adjusting that second cylinder, you then determine how much oil is coming out of that second cylinder. And by the less oil comes out, the slower it will go. Okay, so again, I illustrated the two because these are controlling two different things. One cylinder is controlling the pressure, okay? Or you could think of it as the weight, the amount of weight of this head as it wants to come down. The second cylinder is controlling how fast. So we have pressure and we have rate, okay? They are not the same thing. You usually have two knobs, okay, on your control panel. You usually have two knobs. One is pressure, one is rate. Sometimes the pressure and rate knobs are in different spots. Okay, but it doesn't change the concept. And there are some saws that only give you one knob because they don't want you to have the full control, something like that. But it does matter and it does affect the cutting. Okay, but the amount of weight or pressure into the cut, okay, or the cut force, and the amount and how fast you come down, all are going to affect the quality of the cut. And we will go that in some more videos in the future. But it's important, and I'm using the double cylinder to illustrate an air cylinder and a hydraulic cylinder. Okay, so this guy here, we have an orifice and we'll determine how much oil is coming in and out of this cylinder. More oil means he can fall faster. Less oil means he has to fall slower. Okay, and then this cylinder, we're back feeding air pressure. So if it takes 100 PSI to lift the head, you might put 80 or 60 PSI, and then the head wants to fall at that difference. And then the head wants to fall. And then we say that's too fast, and then we start restricting the orifice or the flow control valve, the rate valve, which is going to slow him down, and he's going to come down nice and slow. Okay, and then all that's determined by what you're cutting, your saw's characteristics, different things like that. Okay, but these are the basics of the saw. You've got your clamp, you've got your head, you've got your two wheels, your idle and drive wheel, you've got your guide arms. Okay, you've got your, obviously your blades running around there. You've got your clamp and your vice jaws. Okay, you've got your drive system, which I said is going to be an electric motor paired with a gearbox, usually of some kind. And then you're going to have your lifting cylinders and cut cylinders, as well as your tension device and your clamping cylinders. Okay, or it's going to have a mechanical system. Okay, so what happens is, if it is a pneumatic machine, a lot of times you turn it on, there's nothing that comes on. There's no hydraulics that need to come on. You just have provided electricity. And when you tell it to turn on, what you're doing is you're turning on this motor, and the motor will spin the pulley, which will then, through the belt, start spinning the gearbox. The gearbox will start spinning the drive wheel, and then we get power to our band. Okay? Sometimes the machine will start coming down automatically depending on the variation of the machine. There's a lot of machines that do a lot of different ways. Okay, other times you got to press the second button that will then start letting it come down at the cut speed. Okay, other machines, let's say we have a hydraulic machine that's fully hydraulic, so no air and no mechanical systems as far as you got to crank stuff by hand. On a hydraulic machine, when you turn the machine on, you're turning a secondary motor on, which is running a hydraulic pump. That is now your power source. So that is running all your power for your lift cylinders, your clamps, your blade tension, maybe even has something on the guide arms up here. So this will move back and forth with a little cylinder. Again, all that stuff. We haven't even gotten to the feed system. So you're going to turn on your hydraulic system. If the hydraulics won't come on, then it's going to be really difficult for the rest of the machine to run. Okay, but we get the hydraulics on. Now, same thing here. You're still going to have an electric motor 99% of the time. Okay, and he's going to run pulleys. Okay, they run a gearbox, they run a drive wheel, so on and so forth. Okay, on a hydraulic cylinder or some pneumatic cylinders, they will combine these two cylinders. They will be one. Okay, so they will regulate the amount of pressure in there and how much oil can come in and out of that cylinder. And the less oil comes out, the slower it wants to fall. If no oil can get out, the head will not come down. Okay, and then generally they have a bypass of some kind. So you have a fast speed and then you have a cut speed, okay, which is real regulated. Okay, so those are the basics. A lot of times for troubleshooting for me is I get called out when either one of the switches doesn't work or they try to turn the saw on, it won't turn on, or the saw will turn on, but you can't actually get the motor to come on. And then those are usually stuff I'll have to troubleshoot. Stuff to do with transformers, contactors, starters, bad switches. Another thing, and then you'll see this more and more, the newer your machine is, they have stuff called safety interlocks. So these have doors on them protecting you so you cannot see these blade. Okay, so if they're open or if the switch is not seated well, okay, that will a lot of times prevent you from either turning the machine on or operating in the correct way. Okay, so all that kind of stuff's going to matter. So different saws have different interlocks as far as what they want you to do. So maybe they want the head all the way up before they can move the feed vise back and forth. Okay, maybe they want the door closed before they'll let you turn the blade on. Different things like that. So again, you got to know the machines. That's why it's important that you brush up on your manuals, look them up online if you got them secondary, secondhand, anything like that. But those are the basics of the bandsaw. I would love to get your feedback. If there's any additional information you would like to know, I know this is relatively rudimentary, but I don't want to go too in depth. We have not covered the automatic system or a feed system of any kind. We will go in that in further videos. If this was helpful, please hit like and subscribe. More bandsaw content is coming. Drop a comment. What type of saw are you running? What kind of shop you're in, as well as what kind of material you're cutting. If you're in the Gulf Coast region and need your bandsaw service, please give us a call or shoot us an email. I Machine Services in Houston, Texas. We travel where you need us. Links are below. You guys have a wonderful day. Thank you so much.